So congratulations. We're almost at the end of our syringe arm project, and I'm really impressed if you've managed to stick with it this far. So here's a few things we're going to do today. We're going to take our bucket and we're going to attach it to the syringe arm, and then we're going to take a look at animating that. And then in a separate video, I'm going to show you how to extract the parts and put them into AutoCAD so you can cut them on a laser. Okay, so here we go. You've got all the parts in your folder here. You've got the arm pre-assembled and ready to go right in here. And oh, I didn't mean to drag that in. I meant to open it up. Great start to the tutorial. Do things wrong in the first 30 seconds. There we go. So we've got the arm right in here. And oh, we've got the linkage. I was starting to bring that in already. Let me just get rid of that for right now because you won't have that in there. I do, however, have the arm with the bucket placed in here. I've got the sheet metal bucket in. So if you don't have that already, you can just drag the sheet metal bucket right into here and place it at the end of your arm. Now it's possible you chose a different method of bucket construction. It's quite possible that your bucket looks different from mine. It's perfectly fine. In fact, that's good. If I wanted to, I could come down here and somewhere I've got a 3D printed bucket that I could bring in here and use instead of that. I've got my 3D printed ugly bucket right down here. And if I wanted to use that file, oh, looks like it just one of those cloud things. If I wanted to use this bucket right here, I'd be able to go in and use that bucket as well. So you can manufacture different designs and try them out to see how they work. But basically, the last video was on the sheet metal bucket, so we brought it in right here. And let's take a look at how we would hook that together. Obviously, we're going to need some linkages. And so in your model of the arm that you had constructed earlier, where we took a look at how it all came together in here, seems like a long time ago now that we started out building that. But right in here, we modeled the linkages. Okay, and I've named this one that connects to the arm linkage arm, and the one that connects to the bucket linkage bucket. And you can use the same techniques that we've used in the past to extract those. So you can go into the bucket and the linkage right there, and you can save a copy of that right there, and that'll put it into your file. Now, when I went in there and did that, I also came back, and so let's take a look right here. You'll see that I took that. Here's my arm linkage, and I just took that right in there, and I created a plane right here. So I created an offset plane. So I only had one of these at the time. Actually, I can drag the timeline back and show you how that came together. So I started out with just the single linkage in here. Then I created an offset plane. I went into my syringe arm and I measured how far apart that was supposed to be, because at the arm end that's going to come out to the outside. So I came in here and used the inspect tool to take a measurement from that side to that side, made sure I stayed on the outside, divided that by 2, offset that, and now I'm ready to go. In fact, I may need to update that because I was doing that for the steel arm. This might not be the right size. So let's just go and take a look in here, and I can get rid of that. That's just where the file came from. I can get rid of that. That's my 3D printed ugly bucket. Let's come in here and let's go inspect. And I want this to go on the outside right here to the outside right there. That's going to be 44 millimeters. Okay, so I'm just going to come in here and I want the internal spacing right in here to be 44 millimeters. That means that plane needs to be offset by 22 millimeters. So when I create that feature right there, it was bigger in the sheet metal. It's going to be a little smaller here. I'm just going to set that down to 22 millimeters for now. And there you can see it's still sitting right in there. And now I just do a mirror of this object about that plane. And I've got the visibility on the construction plane turned off right there. Okay, so because I've got the two different files, I'm just going to save this arm and linkage 2. I'm going to save that for MDF. Just give it a different file name. It's a different part because, again, the parts that are sitting in here, if I saved that under the original file name, that would be wanting to update the linkage in my sheet metal part. So, okay, we come in here, and that probably made that sound more complex than it needs to be because I've got two different syringes going on. You've only got the one, and you want them 44 millimeters apart. And you can come in here, and in your arm, you've got your bucket in here. You've provided a rotational joint right on there, so it's rotating nicely about the end of your arm. And you can come in here, arm end 2, linkage arm, and mine says for MDF. Drag that right in here, shows up over there somewhere. Drag it around so that you're in close. You can see what you're doing. And then let's leave it right there. And let's put a joint on it, capture the position, and we'll put a joint from the inside surface right here. And that inside surface right there. Where's my computer? Rendering slowly right now, something was happening in the background right there, is going to come along and connect to that outside surface right there. And that wiggled like a fixed joint. Make sure that's a revolute joint. And there we are. We're okay right there. You can take that and drag that into position. And because that is a new joint, let's give it a name. And this is linkage to arm. And this is going to make it easier later on if we have to come back and do anything with these. And you can also drive that joint if you want and put it up into a position right here. Now, if we're having problems later on where our bucket starts rotating all the way around, well, you'll see when we put the syringe in, sometimes you can end up with a bucket up over here. We can also take some of our rotational joints and apply limits to how far they can rotate. So you can see in here, we also have the ability to come in here and edit joint limits and all sorts of cool different things that we can do with our joints in here. But let's do that same process for our bucket linkage. We will extract the bucket linkage. Now the bucket linkage, again, is going to mate on the inside right here. Okay, so keep in mind your dimensions right here when you come along. Helps to have a little paper drawing or notes sometimes if you need that. We're just going to measure from right here to right here. Should be 44 on the inside. So on our other drawing, we're going to want this to be the same inside right here. We'll want 44 to be the outside measurements. We'll want 38 to be the inside measurement. So you can come in here and say, well, what's that measurement right there to right there? Yeah, I need to restart my inspection right here. From the inside to the inside. We want the insides to be 38 millimeters apart. And that means with two 3 millimeter pieces, it'll mate up nicely right there. Okay, so let's go and do the same thing. We can extract that file. And here we've got linkage bucket. I've already got linkage bucket going on. And I'd already come in here. I'd created this plane right in the middle, the construction plane. I turned it off so that you didn't have to look at it. You just click on the eyeball to turn it off. And what I'm going to do in here is I'm just going to edit that up. And so instead of being 27.5 that I needed for the sheet metal arm, this is going to be half of 38. Okay, because we just measured the 38, so half of 38 is 19. Comes in a little bit closer, and that's okay right there. And I'm going to save that in my case with a Make sure I do a save as. I don't want to change that original part. This one's for my MDF arm. And I can close that because I'm just working on one thing right now. And here we go, arm end linkage 2, linkage bucket for MDF. And over here, get it somewhere close so I see it all in the same view. And then this one's going to need 2 joints. One's going to come, capture that position. One's going to come from that face right there. To that face right there. Make sure it's on the inside. Oh, that's something I need to do. I need to go back and change that. You'll notice this is not 3 millimeters wide right here because I was planning to make that out of sheet metal. It's only 1 millimeter wide, so that's not matching up with my MDF. So I'm going to leave that there anyway, okay, because I'm going to show you how cool it is that these things are stored in their parts files. I'm going to leave that sitting right there. Just going to say okay, because, I didn't do anything wrong with making the joint right there. I've just now come in, notice these 2 parts are made out of sheet metal. I want to make them out of MDF. So if you've got a problem with anything like that, because we now have this part sitting right in here, we can come back to our original part, come back into the timeline on that original part right there, and where I did an extrude of 1 millimeter to make it sheet metal, I'm doing 3. You probably won't have to do that for yours. But now I just save that, and I'll do the same thing right over here. And we'll see what that does too. Okay, and let's save that. And if you get it right the first time out, you'll probably get to skip over a lot of that. Now, anytime I change a part, you'll notice that that part gets notified in here that it's not up to date. That little yellow triangle right there says, hey, the part in your parts bin is different than the part in your project. So now I can come in here and I can either update the individual part by right-clicking on it and go get latest version, get updates right there. Okay, or I can come up to the top and click right there, and I can say update all to the latest, update all, and then it goes back, searches on the file, and there we go. Now we've got everything made out of MDF right in here. Although I should probably apply some MDF material to that. Okay, I moved something right there. Put those back in where they are. And so for our final step right now, this part should connect to that part right there. And we're going to put a joint in from this face right there, right on the surface, to that face right there, right on the surface. That's going to rotate around nicely. Okay, and yes, now we're in this weird position right here where the bucket is somewhere where we don't want it to be. So let's take a look at how we can fix this to make sure it doesn't happen again. We are going to take this joint right here and we are going to limit the range of movements, and that's our bucket to arm joint. And let's just drive that joint for a second. Okay, so come in here and go drive joint. And you'll see that as we drive the joint, we can take a look at the range of movement through which this bucket actually is able to move. And you can see that we do have some natural limits that are going to happen. Right down here, the bucket's going to start to interfere with the arm. Now, depending on the design of your bucket and your spacing right in here, you may have a different setting for that, okay? But on mine, minus 217 degrees, I'm just going to write that down, is at one end. And when I open it back up, this is going to start to jam up right here because we're going to have our cap on here, and we might be able to go a little bit past here, but we're not going much past minus 82, and that's going to let you open the arm up that way. And these are going to be different. You can still play around with the dimensions right in here. If we're not happy with that by the time we get our 10 milliliter syringe in here, we can still play with some of these numbers and play with some of these sizes to make sure they come out exactly the way you want them when you go to make your arm. But we go from minus 82 to minus 217. So at the bucket to arm joint right here, okay, I can cancel my driving the joint. I can say bucket to arm. I'm going to edit joint limits. I am going to have a minimum, and remember the minimum is the smaller of the two numbers. So even though minus 217 is the bigger absolute value, it is still a smaller number than minus 82. Okay, and you can actually take a look at the rest position, and you can play around with that. That's if you want something to be kind of spring load and come back to a place on its own. It's kind of neat, but we're not going to play with it too much right now. And there you can see that will not exceed those positions right there. Click on OK, and there we go. So now when we drag that bucket around, oh, looks like we might want to apply some joint limits to some of the other joints in there too, but let's undo that. Okay, so watch it when you're dragging things around. Having a few joint limits in there will help everything behave just a little bit more like it's supposed to. And I think from here on in, you know the drill for bringing in a syringe, popping it in right there. And if you have to, you can break some links and adjust the cap and the clamp so that they fit nicely in between right there and right there. Okay, so here comes the 10 milliliter syringe. And let's just bring this up and somewhere over here so it's going to be easier to put into place. I'm just going to click on OK right there, and we'll put a joint from that marker right there, and I'll put it to that marker right there, and that pops in place. Now that's too long again because that was designed for the sheet metal, but I'll just say OK for right now, and then we'll take this end right here and we'll do a joint from that to right on the inside right there. And again, this one I'm going to make it cylindrical just so that we don't get too many, so we don't run short, I should say, on degrees of freedom. And now we should be able to take that joint and come into our joints right here. Where did all my joints go? There we go. So better update all of this. So Rev 14, that was, rename that. That was linkage to that was bucket. Linkage to arm. Rev 15 right here was linkage. Oh, was that? Yeah, that one right there. Rev 15 was linkage to bucket. 10 milliliter syringe to arm, and 10 milliliter syringe to bucket. Okay, there we go. And we should then be able to come in here, and if I surround right here, take a look at what happens if I look at it from the side. And let's just drive the bucket to arm joint. And we'll just take a look at that one. And there we go. Now we don't come all the way around. This joint could come all the way, but it's being limited by the syringe right here, which is exactly what we want to have happen. It's perfectly fine. And when we come back that way, it's being stopped by the minus 82 degrees, which we could get a little bit more room in here if we let that go back further. But you can see this is going to start hitting right in here. So we're pretty much at the limits of how far that can go, unless we adjust the adjustment point or the connection point right on here. Or we can play around with the linkage sizes. You know, you've got a lot of variables in here before you go and make the arm to optimize the arm to the arm and the bucket to your final shape. You can also, you know, say, oh, well, in this design, I can bring this edge of the bucket further forward, make my bucket a little bit bigger to move more dirt. You know, all sorts of things you can do to get slightly better in there, but that's working pretty good. Okay, so now we have all of our joints in here and working together. And so I'm going to click on OK right there. And what we're going to do is now we are going to do a motion study. Okay, now the motion study is kind of a cool thing. And to do that, where are we in here? Motion studies in here somewhere. I think I've done this a couple of times, and now I just have to remember where everything is. So we are going to start by studying what happens on base to platform. And where the heck did motion study go? Just a minute. Right, motion study, right where you'd expect it to be, underneath all of our joints down at the bottom. Just come in here and motion study. Okay, and this little window pops up here, and it is a timeline. And so it says select joints to animate. Well, let's start by animating our base to platform joint. We know that one works really nicely, and you should be able to drag. There we go. Just click on that joint. It comes in here, and it starts out saying base to platform right in here. And now you get a curve that shows where you can add some points on here. So let's come over here to, I don't know, frame 20. Okay, and then you can adjust that angle. And let's see, right now it says we're sitting at sitting at 162. What happens if we change that to 90 degrees? Okay, and there we're in one position right there. That's a little far over. Let's try changing that to 120. That's even a little far. 130. Okay, and then let's bring this back to somewhere in here. We'll set that up to about 180. 180 is nice. We'll actually go a little bit farther. We'll go 230. Okay, and then we'll come in here to 180. And so now what you've got is, let me just put that right down there so we can see the two of them work together. If I take my timeline back right here, you'll see that you can click on play, and you've got that animating back and forth, so you can show how that joint works. And now you can come in and you can bring in another joint in here, and let's bring in the arm to boom joint. Okay, drag that. Should work when we drag it in. Double click on it, I guess it is. And arm to boom in right here. We can rotate that up and down. Now, right now it's at minus 109. So let's give it a timeline right here. We're just going to click on a point right there. We'll leave it at minus 109. so we won't move it. We'll come in right here and let's set that to minus 130. Oh, that was arm to boom. Okay, fair enough. Minus 160, minus 180. Can't go that far. Minus 170 seems to work. And then let's come back up in here. We'll add another joint. And right now we're at minus 170. Let's bring that up to minus 150. We can come. There we go. So we flexed that one. We'll leave it right there. And so we got a little bit of animation happening on that one. Let's drag our timeline down. Oh, there you go. You can see that's going back and forth. We've got a couple joints rotated right there. We'll bring in boom to base. There we go. And when we animate that, we'll hold that position right there. And why not put another key in right there? Well, that's minus 60. We can bring that down. Let's try minus 80. Oh, sorry, minus 40. There we go. And then we'll add another key right in here at minus 20. Something like that. And now we've got an animation of our joints all spinning together right down in here. Oh, let's take that bucket to arm right in here. And you can animate your bucket to arm coming together right in there. We'll have it right in there. Now this one we know went from about minus 217 to minus 82. So let's leave it just right there. We can create a new one right here, call that minus 82. There is a way to delete that one. We'll set that to minus 82 as well, just so we don't get big jumps in the animation. And we'll set this down to minus 217. There we go. And so now we've got a little animation of our arm playing together in there. And it might take a little while for it to run because it goes kind of slowly. Okay, so I'm just going to click OK on that and zoom in right here. And so now we've got this whole arm. It's set up and it's actually ready to create a little animation of that. Come over to your render. And the in-canvas render we've used before, but there's also a way that you can do an online render. So if you click on your render settings, where's your setup? Scene settings, and you can play around with the ground plane, and you can put different environments to control your lighting, and you can add all sorts of backgrounds, control your camera angles, all sorts of neat things like that. Let's see, scene settings. You can put a decal in for your background or on the object. Let's see, there's in-canvas render, capture image, render right here. There we go. Pick your render settings, and you can come in here and tell it that let's just go for an 800 by 600 render. Okay, something fairly simple. And we'll do that on the cloud renderer and just click render. Now what this does is that sends that out to AutoCAD on the cloud, and Autodesk is going to go through and render this for you, and it'll keep you updated on the progress. And when it's all done, you should get that file back. Okay, now after your AutoCAD has rendered your file for you, you should get a picture of it back here. And there's the rendering gallery right there. And you can get a nice picture of your arm all rendered together in there. Now, what you're able to do is tell it that you want to do a motion study because you've already programmed in your motion study. So click on that. And so your motion study is going to come in right here. And you can have multiple motion studies. So it's asking you which name do you want. Um, your render quality, you can go standard or you can go to a final render. You've got to watch as you go to the final render though, you'll exceed your limit of cloud credits because you're using Autodesk's online computing ability. And you've got a free educational account, then you're limited in how much of their computer you get to use. So again, if you increase your uh, dimensions too much, you're not going to get anything too fancy. Basically, if you're a commercial client, you can work on, last time I checked, $1 American per credit was ballpark what would happen, but you have to buy them in bulk. So anyways, I'm willing to say this is $12 of computing time that Autodesk is investing in my educational work. And thank you very much, Autodesk. I am going to render that motion study we just created. Okay, so I can close that and Autodesk is going to take care of that. And when we're all done, they'll let me know what's happened. While we're waiting for that to happen, you can also take a look in here and you'd think you'd do your animation under animation. This is more designed for creating exploded views and assembly diagrams for parts, and I haven't really played around with it all that much. But if you're looking for more information, remember the help is always up here and there's information online and there's lots of other tutorials out there. You do not have to do this for part of this project. In fact, even the motion study is nice to have at the end of our project. And when it finishes up in a moment, we're going to take a look at what that looks like. Okay, so Autodesk has finished our animation here, and we've got a play button down here now. You can click on that. Actually, click on it to make it big. And you can go ahead and you can play your arm, and it's animated right in here. You can see the base turning, the bucket dumping. The syringe is all linked together and sliding back down there. I just realized that I never went back in and edited the lengths of the clamp and the cap for that syringe, but that's okay. It should be moving up and down here. I'm not quite sure what happened to my motion study in there. I may have to go back and edit that up. And, there's probably better camera angles to play around with in there. But basically, you can set it up to be as fancy as you want, and you can download that motion study as a video. And so that's all very cool. Now, another thing that you can do with this project when you've got it all done is you can come back to your design right here and you can pose it however you think makes it look really good. Doesn't really want to pose nicely for me right now. Might be better if I go through and drive individual joints to get it into yep, I don't want it in that position. So come into your joints and let's set our base to platform right here. Just come in here and drive your joints. Square that up. Okay, come in here to boom to base. Drive that joint. Bring it down a little bit. Base to arm. Where did base to arm go to? Joint. Arm to boom, boom to 30, syringe to base, rigid group, bucket to arm. Now we can drive that one down. Oh, gotta click on there before I can drive anything else. Drive this joint. Bring that bucket around a little bit right in there. Boom to base, arm to boom right here. Okay, on there, arm to boom. Drive that joint. bring that down a little bit like so. So that's a nice position to leave your arm in right there. So just click OK and fill up the screen with it kind of. Now, if you want, that does have the options. You can insert somewhere in here, you can insert McMaster car components, and that gives you rivets and screws and the like that you can pop right into all of the little holes that you've left open for them right along there. But what we're going to do right now is take a look at one other thing you can do to finish this up. Of course, one thing is to bring in the excavator control board and the excavator control box that you've put together. You can put them in here. You can create a motion link between the syringe and that box and the syringe right on here. So when you lift one up and down, you control the other one. But just want to take a look. You've been working hard at this, and excuse me. A good way to share this with a lot of people is to save the file. There we go. It's taking a moment to save right here. Oh, this is thrilling. There we go. And then when you've got it all saved, you can come in here, and if you right click on the file right here, you can go share public link. Okay. And share the latest version using with anyone using this link. So what that means is, do they get just this fixed version, or if you come and make changes, do they get the latest version? I just like this fixed version. That's what I want them to be able to look at. Do you want them to be able to download it? You could have that. And you require a password to access it. I've got none of those options turned on. So I am, let's see. There we go. And we can, excuse me, we can turn some of that on and off right here. Oh, it's laggy right now. Turn that on, click yes, and I can copy that link right there. Now I can send that link to anyone. Now, if I open a web browser and I paste that, yeah, link right into there. So you can share this with anybody who has anybody who's got a web browser. You can take a look at this on the phone or anything like that. You can see right in here. Oops, I should go back and fix that before I share it. So if you've gone through and you built all this and you want to tell people what you've done with the last 8 weeks while you've been locked up at home, you can say, I learned how to make something like this, and that's sometimes cooler than looking at a 2D drawing. Okie doke. So there you go. That's one way to finish off this project.